Hey everyone, continuing with our trigonometry integration, we have these squares. We'll first start off with sine square and cosine square. So we have sine square x and cosine square x. So you know that you are not able to directly integrate this, right? Because if you use the power rule, you'll be introducing a new term, as I'll show you. So if you're going to use the power rule incorrectly, this would be the quote-unquote integrals that you're going to get, which is clearly wrong, right? Because you're introducing a new variable term. As such, these two answers are wrong. As a result, we have to kind of express each trigonometry square differently in a way that is integrable, right? So let's just take a look at sine square x first. So we know that sine square x has a few appears in a few relationships. So sine square x plus cosine square x equals to 1, and also in cosine 2x equals to 2 sine square, equals to 1 minus 2 sine square x. So let's take a look at the first one. Sine square x plus cosine square x equals to 1. I can express this as sine square x equals to 1 minus cosine square x. And obviously you know that, well, I can't integrate cosine square x, right? So clearly you can't use this formula, relationship here. What about cosine 2x equals 1 minus 2 sine square x? If I were to make 2 sine square x, sine square x as a subject, I will get 1 minus cosine 2x, then times a half. So you realize that you can integrate 1, you can also integrate cosine 2x, so this is the form that we want, right? So as such, we will be integrating sine square x as integrating half minus cosine 2x over 2 dx. What about cosine square? If you go back to the first formula, we realize you'll be getting cosine square x equals to 1 minus sine square x, which again, we can't integrate sine square x directly, so this is not the ideal answer. Let's look at the other one, cosine 2x. Well, cosine 2x equals to 2 cosine square x minus 1. And well, if I make cosine square x as a subject, I'll get half 1 plus cosine 2x, and based from the sine square x, you can integrate 1. You can integrate 1, you can also integrate cosine 2x. As such, we'll be integrating cosine square x as integrating half plus cosine 2x over 2 dx. Then realize it's very simple. So let me just integrate sine square x first. So I get half x minus sine 2x. So cosine becomes sine. Now I must divide by the derivative inside, which is 2. Therefore, 2 times 2 is 4. Then lastly, plus c. For cosine square x, the only difference is the minus sign becoming the plus sign. So it's basically half x plus sine 2x over 4 plus c. And there we have it for the sine square and the cosine square. In general though, we have a general formula. So where we have fx as a linear function. So obviously a is not 0, because if a is 0, then, you know, like for example, sine square 3 is a constant, right? So we are not interested in a being 0. We have sine square integral or sine square fx dx equals to half x minus away sine 2fx over 4a plus c. For cosine square, we have, again, similar, just that it's a plus sign. All right, x over 4a plus c. So we have this general formula. Don't worry, I'll give you an example shortly. Let me just draw this box first. Okay, so based on this formula, right, we can do an example. So let's say I got sine square. Let's say I have 2x plus 1. Okay, 2x plus 1. So if you don't really have to remember the formula, right, you can always do this, right? Just, you know, express it in terms of this, right? So we have cosine 2x equals to 1 minus 2 sine square x, right? So in my head, I'll be, okay, so I have half 1 minus cosine 4x plus 2, because 2 times 2x plus 1 equals to 4x plus 2 dx. And then I will have half x minus away sine 4x plus 2 over 2 times 4, because derivative of 4x plus 2 is 4, then must times the half, so 8 plus c. You notice it kind of holds with the formula here, so where sine 2fx is basically sine 4x plus 2, derivative of fx is, in this case, 2, because fx is 2x plus 1, so it's the final answer here. Another example, cosine square, let's say 1 minus x, this time around I don't use positive numbers, raised by the formula. I mean, you don't have to really follow the formula, right? You just need to go by the fact that, okay, you can always just do this. But the general idea is that for sine square and cosine square, always related to your double angle formula. So cosine square 1 minus x, so, well, based on the formula, it's simply minus sine 2 minus 2x over 4. Reason why it's minus now, because a equals to minus 1. So I put a minus 1 outside to the plus, it becomes a minus. And not forgetting your plus c. So there we have it, the general formula for sine square fx cosine square fx, where fx is a linear algebraic function.